Okay.
This meeting is being recorded.
So, welcome to our IQP project. This past summer and into the fall semester, we've been working on designing an international support community for educators in robotics. Um, so my name is Swar Holmes. We also have Alex, Andy, Trang, and Tom on the team. For our advisors, we have Brad Miller, who's a robotics professor and a senior fellow at WPI. We also have Professor Doran, who is going, he's the director of the global lab, but also going to be the director of the project that is upcoming and related to our project. For our problem statement, we researched, developed, and tested a working prototype of an online professional learning community for teachers and learners around the world. For this, we decided that we needed a space that could act as a technical platform and a community. Technical platform where students can ask questions, and a community where people can, I don't know, feel comfortable talking. Here's our project outline. We have the background, we have the methodology, we have the results, and then we'll finish it off with recommendations and final thoughts.
All right, so to start off with the introduction and background. So for STEM education is for science, technology, engineering, and math. STEM is dated back to the 1990s. Just recently, they want to add into art and architecture into the STEM acronym for STEAM, all STEAM ahead. Next part, we want to introduce into research. In the very beginning, we want to do some interviews to learn more about what STEM education. So we wanted to conduct an interview with Annie Hughes to learn about building up a self-sustaining community. Next, about the reason for STEM education, and more specifically with robotics, is that there's a huge demand for STEM education and for STEM careers. So as of right now, there's about 9.8 million occupancies in STEM, and in the next 10 years, we're expecting about a 10% growth. So there's a big emphasis on creating STEM education and STEM programs in order to encourage kids into getting into the STEM field.
We also would like to touch on some of the issue and barriers in accessing STEM globally. We first want to address the women and minority, as well as the lack of resources. For minority and women, they have been found to have been taking less courses and achieve less. Have harder time achieving the higher education regarding STEM field. A lot of this reason come down to stereotype, cultural stigma, lack of role models, academic preparations, and a lot more other problem that systematically go into their access for STEMs. Regarding lack of resources, we also want to talk about how it's reflecting into supply and resources. There's definitely an uneven development in access of hardware and software globally, and we can see this in the inconsistent access to Wi-Fi, hardware itself, or even the knowledge due to government's data control. We also kind of look closely into teacher readiness, since there is currently a lack of STEM teacher around the world, as well as lack of training system for them to adapt with the new and updating technology. Um, we also kind of look into the priority as itself, since it's kind of affecting the grant towards STEM education as a whole. There have been an interesting find that developed country lost interest in STEM, while a developing country has increased their interest in STEM education and STEM as a whole. Some of the programs that currently trying to tackle this issue, including First Global, that recently happened in Geneva with over 180 nations around the world participate, as well as Girls Who Code, trying to narrow the gap of gender. There's also a lot more other program currently is going on for STEM and robotics, like VEX Robotic or Engineering for Us All, and a lot more as well. We kind of want to, for this specific project, kind of want to look into a global platform that be able to tackle local issue and make more impact. these requiring of flexible curriculums in which application can be flexible to narrow down to local need, as well as flexible in available material. We also want to emphasize the need for well-trained local educator who can modify, adapt those curriculums as needed, as well as getting updated with new tech. The question that we're addressing here is how to build a creative and inclusive learning environment, taking in multiple local voices in one global program. As mentioned earlier, we are the support system for a big project called Open STEM, which is a joint effort between WPI and DECA, first to tackle the global STEM education by providing a low-cost robotic system with the building educational and software support, which is our current project is surrounding the XRP robot, as you can see on the right hand, and a lot of those robots already been sent out. More detail will be mentioned later on. Here, just like organizational chart, seeing where we are in this Open STEM project. We are part of the 3 sub-team for it, including hardware, curriculum, and support, working together. Again, we'll talk about it in more detail as well.
So next, we're going to go over our methodology. So our methodology is going to consist of essentially 4 things. We first did research, then we define our audiences and our goals, into which we proceed on to looking at what type of prototype we actually want. And then with the tests, we want to see what we want to learn from our prototype. Yeah. So research, we essentially looked a lot of the background for us is essentially a lot of the research. And using the background that was just talked about, we can then identify issues and then define them. It's our next thing. So when we define everything, we got 3 different things that we want to address, which is our target audience, the technical platform that we want to build, and then the community. So our target audience is mainly teachers internationally, as well as really any students interested in STEM. Those students will mainly be the students of those teachers, as the course is delivered to the teachers, and the teachers can use the course to deliver the same type of material to their students, for example, or make their own material. Then our technical platform, we define of what we want from it. So we want it to be easy to use, accessible, as well as easy to maintain. So no one will have trouble going into it, and we in the future will not have trouble keeping up with an increased amount of users in the platform. And finally, we're looking at the community. We want a self-sustainable learning platform so the teachers can eventually help each other, and it's not as much stress on us or staff to essentially help them through all problems that may come up with the course. And then we want to build a global network so the teachers can talk to each other and make the course itself fun and engaging. So now we want to look at different types of platforms that are already out there in terms of forums and support, as that's one of the main things that we want into our prototype. So the first one is a Canvas discussion page where people can ask questions under specific topics, and then those can be answered, and then those answers can be uploaded. The same can be done in Slack, in Stack Overflow, where someone can ask a question, that question can be uploaded, and then a response to the question, whichever response works the best, can be uploaded to the top. And then finally, also Discord forums and support, which is a new feature in Discord, also allows this type of support, but it's relatively new, so we don't know as much about it yet, but it's also seemingly an effective tool. And we also looked at different Discord servers to see how they have also built their support tools and community. Then in our prototype, we also want to build in community. So we are using this. So we're also looking at different platforms that have already been built, and then seeing how those platforms have been able to build a community, and then seeing how we can kind of replicate that and make people comfortable while using our while creating our own platform. So then we also want to test all this, all that we've built. So we want to release the platform. We want to get course feedback in the platform and also technical feedback for the platform. Then as a team, we're going to discuss this feedback. We can give feedback to the people who are building the course as well as the people who are building the platform. Then we can implement that feedback into those things and then finally release those implementations. So now we are actually building a platform. So first we had to make some assumptions in terms of us thinking of what the teachers would need to be able to complete the course. So it was that they need to have some type of internet access to originally be able to access the course and the community. Then they would need some type of technology to develop the code, as well as a base level STEM knowledge, as we're assuming that we're giving the robots out to teachers who are already teaching some type of STEM, and that they are English speaking so that we can give them the course as it is. So in our platform selection, we looked at different types of different topics like community chat. We eventually chose Discord. For website, we were originally building our own, but WPI Marketing has taken it over. Then course delivery, we're currently using Canvas. And then finally for discussion Q&A, we're using Discord forums. Then this is our Discord community prototype of what we've essentially created. On the bottom left, you can see the forums of what we're going to be, how you can ask questions and then keep the questions up there, and then we can respond to those questions inside the forums. And then there's some community building, and we have an introduce yourself channel, pets channel, off topic general, all the stuff that people could just talk in. And so now we coming with the results of what we got from our platform. So some feedback and observation that we got was that it was actually really difficult to join some of the platforms. The Canvas page doesn't have that many people in it. And as we are advertising Discord in the Canvas page, the Discord will naturally also not have that many people in it. There's around 40 in the Canvas page, maybe 10 in the Discord. Then there's no central repository for knowledge. So there's no place where everyone can just go to look up any, if they run into any problems, there's no built-in frequently answered questions or anything. That just kind of doesn't exist. Some hardware has been faulty. There's not been data sheets, as well as there's one teacher brought up a great document of how there's a lack of robot build instructions, so they had no clue how to start the course even. And then finally, there was another teacher who said that they really want to use Blockly, but there's no support for Blockly currently. So our results are that we handed close to 200 robots out. 47 Canvas participants, only 2 have completed the quizzes, so a lot of people have not really even looked at the Canvas page for that long, only 1 to 2 hours, only 10 people in the Discord. But there are a handful of students interested in WPI, so there is some success in all of that. Then what the team has talked about is potential uses and applications for the future of the robot. For example, we can develop multiple curriculum with the robot abilities. It doesn't have to be only one. It can also be put into many different, depending on people's abilities, you can also aim it at different skilled individuals. You can initiate training program for robotics clubs and teams. You can do outreach activities to introduce STEM across the country or across the world, really, to places where they haven't been able to see much, haven't been able to be introduced to this type of topics. And then the teams are also able to develop their own programs with the robots. Like we talked about, teachers are able to build their own curriculums with the robots and then give those out to the teachers. Yeah, go forward.
Okay, so moving on, I'll be talking about recommendations and next steps for the program. So we divide the recommendations into kind of 4 buckets. So first we have course delivery recommendations, then we have internal operations recommendations, which is more on the organization of our team and running this program. Then we have the hardware and software recommendations, and then finally next steps. So for course delivery, first and foremost, we want more documentation, because this will better the support. As Tom previously said, there was kind of no one place for us to get our information from to provide that support, which was a little difficult for us to provide answers. Second, the course material needs to be improved upon. We felt that this was a little rushed due to needing it for Geneva. But yeah, there's just a lot of work that can be done to make it more interactive and engaging for the people participating in it. Also, as previously said, it would be cool to adjust the curriculum for students. It was initially for educators to learn about the robot and then eventually provide curriculum to their students, but we found that students were very interested in directly interacting with our platform. Then fourth, we should move to a new platform. Canvas had a lot of difficulties for everyone in joining since there were so many steps, but if we could find a platform that was more available to everyone and easier to join, then it would be a lot better for the program. So next, for internal operations recommendations, our first recommendation is to employ a full-time technical expert who can lead the team in the support system. This would be beneficial so we can just provide better support, and that kind of leads into our next topic of increasing communication between teams. We felt that even though the open STEM curriculum, we kind of divided it into 3 buckets of hardware and curriculum and then support, it was kind of hard to talk to everyone who is in each of those kind of sectors of the organization, and there also aren't too many people working on the project. And then our third recommendation is to train WPI students to work as support and get them familiar with the robot. Since we came in and this was our project to develop on, we didn't really have too much time to work with the robot ourselves and get familiar with the curriculum, especially because the curriculum was a work in progress. So it would be beneficial to get more WPI students involved, and that can create a better support system and increase the communication between everyone. And lastly, we should follow a development cycle between all the teams so we can all have sync up meetings and know what we are currently working on and or iterating on for the program. So for our hardware and software recommendations, as previously stated, there were some inconsistencies that we saw between the hardware and the documentation. We would like to see that fixed. We would also like to make Blockly functional. This could make it easier for a lot of students to use the robot and also make it a lot more flexible for teachers to create curriculum. And then our third recommendation for hardware and software is to retrieve and publish the data sheets on the course delivery platform. Given that our team couldn't find the data sheets that we needed to give proper support to a lot of these people who are asking for it, it would just be better to find the proper data sheets and publish them to the course so everyone can see them. So for next steps, we suggest improving the course material first, then to get more people on the course. Providing weekly challenges would be beneficial in the program to get people more engaged. We did only see 1 to 2 people working on the course for 1 to 2 hours. It would be better to constantly be talking to them and giving them more ideas so that they can be engaged with the program. Fourth, we suggest a scholarship. Given that there were so many students that were interested in WPI and applying to WPI, it would be cool to see that participating in the Open STEM program would have some sort of weight or help them in their application somehow. And then fifth, we would like to ask for feedback at the end of the course. This would be helpful for anyone who plans on making it better. We were going to implement a survey at the end, but we didn't really have the chance to, and there could be a lot of information coming from that. Some final thoughts are that this was the first iteration of the Open STEM support system, and the course is still a work in progress and needs to be finished. Before scaling up and providing this course to other people, we should first finish the course and then also reconsider the platforms that were decided on, because these were platforms that we chose for our prototype, and that might not necessarily be the best option. And then third, there needs to be more WPI student involvement to properly run the program. And yeah. Final thoughts, questions? Trying, are you still recording?